Today we are going to discuss algebra of functions and composition of functions. Just like we can add, subtract, multiply, and divide polynomials, in the same way we can add, subtract, multiply, and divide functions. So if you're given a function f of x and given another function g of x, and we're trying to figure out the addition function, which is f of x plus g of x, we can simply go ahead and add those two functions and we will have our addition function. Similarly, we can subtract the two functions and get the subtraction function. And remember, when we subtract, to use the parentheses and distribute the negative sign into second parentheses into the second function, and that's going to be my subtraction function. Similar way, we can do the multiplication function. We can multiply the two functions just like we multiply two polynomials. We can also divide two functions, find the quotient of two functions. One thing we need to keep in mind that we make sure that denominator is never equal to 0. So when we are dividing, we got to be careful the denominator is never equal to 0. We got to exclude the values that make my denominator equal to 0. Let's look at some examples of algebra functions. So here's an example. We are given the function f of x, which is x squared plus 3. We're given the function g of x, 2x minus 5. And part A, we're supposed to find out the addition function. So what we're going to do is we're going to add the f of x plus g of x, and that's going to be my addition function. There's no like terms. Actually, there are like terms to combine, plus 3 and negative 5. So this is going to be my addition function, x squared plus 2x minus 2. For part B, we are looking for multiplication function, f of x times g of x. We can write it as a product function, f times g of x, which is going to be x squared plus 3 times 2x minus 5. Let's go ahead and FOIL these. So x squared times 2x is 2x to the third minus 5x squared plus 6x minus 15. And there's no like terms to combine, so this is my product function, 2x to the third minus 5x squared plus 6x minus 15. For part C, we're looking for f of x minus g of x. We're looking for the subtraction function. So all we have to do is subtract f of x minus subtract the g of x from it. Don't forget to use the parentheses, because if you don't use parentheses, you will mess up with the signs. So x squared minus 2x plus 7 is my subtraction function. Lastly, we're going to look at the quotient, part D, which is f of x divided by g of x, which we can write it as f over g of x, which will be x squared plus 3 divided by 2x minus 5. We must say x cannot equal 5 halves here, because if x becomes 5 halves, then my denominator will equal 0, and I'm going to be in big trouble. I'll have domain restrictions there. For a rational function, we cannot have a 0 in the denominator. It makes my function undefined. So x cannot equal 5 halves. All right, now we're going to talk about composition of function or composite function. So another operation on the functions is called composition of functions. If f and g are two functions, then their composition, f of gx, is same thing as f of gx, or g of fx is g of fx. So what happens here is your inner function changes. F of gx, that means the g of x will be the new x for the f function. Let's look at some examples. So here are several different parts, A, B, C, D, E. I'm going to start with part A. So this is my f of x, and this is my g of x. I'm trying to find out f of gx. I personally like this form more. It makes more sense to me. It makes more sense to me what's happening. So f of g of x. What is g of x? G of x is, first of all, think about what is the f function. What does f function do to something that goes inside? Well, it squares. Whatever goes inside, it squares it and adds a 3 to it. What does g function do to it? If something goes inside g function, it multiplies by 2 and subtracts a 5 from it. So keep in mind, f of this new x, this is going to replace the x in the f function, okay? So what does f function do to something that goes inside? It squares it and adds a 3. So 2x minus 5 squares it and adds a 3. We can go ahead and simplify, and that's going to be 4x squared minus 20x plus 25 plus 3, which is 4x squared minus 20x plus 28. Okay, and that's my f of gx. For part B, we're looking for g of fx. So I like it in this form. So inside my g function, my new x is going to be f of x. What's going inside the g function? It is going to be x squared plus 3. X squared plus 3 is going to go inside the g function. What does g function do to something that goes inside? Well, let's look at the g function. It multiplies it by 2 and subtracts a 5 from it. So 2 times x squared plus 3 minus a 5. 2x squared plus 6 minus 5, which is 2x squared plus 1. Okay, and that's going to be g of fx. Now next, you can also compose a function on itself. For part C, we're looking for f of fx. I'm going to go ahead and clean this up so that I have space to do part C and part D. I don't want to do it on the next page. So I'm going to be clearing this and looking at part C now. Okay, so for part C, I got f of fx. That means inside my f function, I'm putting f function. So what does f function do to something? First of all, my new x will be x squared plus 3. Okay, this is going to be my new x. Whatever f of x is, my new x. What does f function do to something that goes inside? Well, it squares that something. Now I'm just going to keep it as x squared plus 3. It's going to square it and add a 3 to it. That's going to be f of fx. G of gx, well, for g of gx, it's going to be g, and inside, g function is going inside the g function. So my new x is going to be 2x minus 5. What does g function do to something that goes inside? Well, g function multiplies it by 2 and then subtracts a 5. And again, we can simplify. I'm not spending too much time on simplification because I'm assuming that you already know how to simplify. 4x minus 10 minus 5, which is 4x minus 15. Here's part E, f of g of negative 2. Now here we can do it in two different ways. One way is, one method is we can find f of g of negative 2, which will be f of g of negative 2. So what is g of negative 2 going to be? We know g of x is 2x minus 5. G of negative 2 will be, let me write on a side. We know g of x is 2x minus 5. G of negative 2 will be 2 times negative 2 minus 5, which is negative 4 minus 5, which is going to be negative 9. So g of negative 2, we just found out that it is negative 9, so I'm going to plug it in there. Now, what is f of 9 going to be? F of negative 9 is going to be, I'm going to replace the x by negative 9 in the f function, negative 9 squared plus 3, which turns out to be negative 9 squared is 81, positive 81 plus 3 is 84. Okay, and the other way we could do part E is, let me erase part C and D. Other way we could do part E was, we could go ahead and find f of g. Because we want to find this, we can find out f of gx. F of gx, we had just found it out. Okay, so I'm just going to do the work to find it out again. I erased it. F of gx is 2x minus 5 is the new x that's going inside the f function. What does f function do to something that goes inside? It squares it and adds a 3. Now, this is my f of gx, 2x minus 5 squared plus 3. Now, I need to find this f of gx. I don't need to find f of gx, but I need to find f of g of negative 2, right? So I'm going to replace the x by -2. Let me rewrite it. It's a little messy. So replace the x by -2 in this function. 2 times -2 minus 5 squared plus 3, which turns out to be -4 minus 5 is -9 squared plus 3, which turns out to be 84 again. So either way, it is correct. Okay, that's all for function composition.